This is from Buentedura. A key component of using games in the classroom is designing an assessment process to go along with them. The first place to start is in the selection process for that game. We've already seen several of the key items that go into this. So, to recap, you want to match your educational goals to the game genre you've chosen. You want to perform a critical game type analysis on the game you've selected to make sure that it will work for your intended goals. And you also want to bring into consideration both the narrative structure of that game as well as the player types it will appeal to in deciding whether it is suitable for use in your classroom. And you want to keep in mind one more thing. We know that games have built-in road marks that tell you how far along you are to victory conditions. We know that games tell you, well, you solved this puzzle better or worse, and that is sometimes measured in terms of score, sometimes it's measured in terms of the goodies you get along the way. One thing you should think about very seriously at this stage is whether those goodies, those scores, etc., all those types of game events that mark your progress and degree of expertise within the game are suitable, are appropriate for assessment purposes. In other words, is it possible that you might be able to use as a component of your assessment practice the score that a student got in the game, for instance? Okay. So this is, shall we say, the first stage of designing this assessment process. But then you need to go further along. And what you need to think about are your assessment tools. Now, in general, you're not going to be introducing games into the classroom in a vacuum. In other words, you will be introducing them in the context of an existing classroom practice and in particular an existing set of assessment tools. So one of the questions you have to ask yourself is, in addition to those assessment tools that might be intrinsic to the game, such as the scores that you've already decided you're going to use, are your existing assessment tools up to the task? And this is a question I recommend asking twice. The first time around, you want to ask it sort of in general perspective. So, if your answer is yes, they are, well, you don't want to just say yes, they are, and that's it. You want to justify explicitly for yourself what are the general characteristics of the assessment tools you already used before you introduced games in the classroom that would justify this answer. If, on the other hand, your answer is no, they're not, so you look at your assessment tools and say, well, gee, the game is going to introduce certain types of learning, certain types of experiences into the classroom that these tools can't measure, well, you need to ask yourself then three questions. The first one is whether the existing tools were ever adequate to measure what's going on in your classroom. And this is an important point. I find that frequently when people introduce games into the classroom, they get benefits not just from the introduction of the game, but from actually questioning their classroom practices beforehand, and in particular questioning the types of assessment tools they were using. So you may find that it's not just a question of you need to assess things that happen with the game, it's a question of your assessment tools didn't work very well in general to begin with. The next question is, if you're going to make new tools, are you planning to apply them both to game and non-game courses? In other words, are these tools just going to be specific for this game, or are they going to be used more generally? And finally, you also need to ask yourself honestly, well, am I just trying to save some time and effort by creating one set of tools that works for all courses? And if that's the reason I'm doing this, well, am I shortchanging the other courses then, and of course the game course, by not optimizing the assessment tools for them? So once you've gone through this general answer to these questions, I recommend focusing on one touchstone for the assessment tools in particular, and that is how they measure up against Bloom's taxonomy. Now, Bloom's taxonomy has this scale of different types of cognitive processes, and as you go up the scale, the cognitive processes become more involved, richer, and in general that's where you want the outcome of the educational process to land. In other words, you want your students to go beyond just, say, remembering facts to being able to analyze knowledge, information based upon those facts, to being able to create new knowledge, new things based upon this knowledge, these facts. However, it is frequently the case that assessment tools tend to stay at the lower level of Bloom's taxonomy. So, for instance, if you're teaching history and your main tool for assessment is a multiple choice test in which you're asking students to repeat from memory the dates of, say, key battles in the Civil War, well, you're operating primarily at the remember level of things. Now, not only then is your assessment tool not reaching to the upper level, so it's not telling you what your students can do at those upper levels, it's also particularly badly suited for what games can do. And here's where you want to go back to Jim Gee's research and why I emphasize taking this step of looking at Bloom's taxonomy. Because if you look at the research on games and learning, you find that the bulk of the learning experiences that games bring to the table operate at the upper levels of Bloom's taxonomy. So, assessment tools that operate at the lower levels will completely miss what games provide to the classroom, the richness that games can provide, and ultimately the main reason we're talking about introducing educational gaming as a useful classroom tool. So, once you've taken this step of matching your assessment tools against Bloom's taxonomy, and then matching your game's learning goals also against the taxonomy, and then matching each to the other, you're ready to take on these questions for a second round, and now answer them not just in general, but with a very specific view to addressing any issues that might have come up in your analysis via the lens of Bloom's taxonomy. Once you have gone through this process of rethinking, redesigning, and repurposing assessment tools, you should ultimately wind up with something that looks a little bit like this. You'd have one set of tools that would be optimal to assessing what goes on in a classroom that doesn't have games in it, a second set of tools that would be optimal for assessing student learning in a classroom with games in use in it, and then the intersection of the two, the sweet spot, if you will. And what you should hopefully have is a set of assessment tools that primarily lands within this sweet spot. And in seeking out the sweet spot, you should also remember that the introduction of games in the classroom not only changes what it is you're assessing and how you're assessing it, but also changes the opportunities that are available to students and to you for assessment. In other words, it introduces new opportunities for formative assessment that you might not have had before. All right, so you've gone through, you've fine-tuned your assessment practices, everything looks good, you use the game in your classroom, and the results look very good. So you should be ready to just go ahead and proclaim the use of the game a triumph, right? Well, not so fast. There's one more thing you have to take into account, and that's the following. When you introduce a new tool or technology into a classroom setting, you sometimes get positive results that are not due to what that tool or technology brings to the table in terms of your students' learning, but rather are due to the fact that you introduced novelty into the environment. And the collective name for this type of effect is known as expectation effects. And there are many of them, but there are four major forms. The first is the placebo and halo effects. The placebo effect is very simple. You introduce a new technology into the classroom. The teacher and the students believe it will help them to learn. So even if the technology is in and of itself not really contributing much to students' learning, that belief means that they will actually do a bit better on exams or whatever other form of assessment you've set out for them. And the halo effect is closely related to this one. This is what I would call almost the coolness factor of a technology. And you sometimes see it when you introduce Well, it's essentially the same technology into two different classrooms, but in one classroom the technology looks cooler than the other, even though it's doing the same thing pretty much in both of them. So that coolness factor colors everything around that technology. It's therefore perceived to be better, more effective, and in turn that results in better observed outcomes for the students, even though there's no real differential in terms of what the cooler technology is bringing to the table. The Hawthorne effect is a different type of expectation effect. The Hawthorne effect describes a series of experiments that originally took place at the Western Electric Company in the Hawthorne Works, hence the name, back in the 20s, and they can be described very simply. Whenever you're observing a phenomenon, whenever you change a variable in an environment, you're going to have a change in the outcome, not because of something intrinsic to the change you made, but because you've signaled to the people being observed that something is changing. And in the Hawthorne experiments, what was being changed was the degree of lighting in workers' environments. So some workers had their lighting increased and their productivity went up. Other workers had their lighting decreased. And you know what? Their productivity also went up. And in analyzing the data, what became clear was that the key factor was not lighting, but the fact that a change was being introduced into the environment of the workers. A third type of expectation effect is the John Henry effect. And this is one that affects not so much the students that are being exposed directly to, shall we say, the new technology like the game in the classroom, but rather the students that you might be using as a control in a different classroom that say, well, we didn't get the game, but we're just as good as they are. We're going to work harder to make up for the fact that we didn't get the game, and sure enough, they get better outcomes. So the effect is named after John Henry, and if you know the folk ballad of John Henry, you know that John Henry was the man who decided to challenge a machine and beat the machine, but at the cost of his own life. So in the John Henry expectation effect, what you see is that the group that didn't get the technology outperforms the group that did get the technology, even though perhaps the technology was bringing something useful and valuable to the table. Finally, the Pygmalion effect refers to the fact that teachers that are told that they should have higher expectations of the performance of their students will in fact determine the actual performance of the students. And the original experiments, which were carried out by Rosenthal in the 60s, took the form of dividing students into two groups chosen completely at random. But the teachers for one of the groups were told that that particular group had been selected because their IQs were higher than that of the other group. That was not the case. The IQs were completely randomly distributed throughout the two groups. But in fact, the group that the teachers had been told was, if you will, the smarter group, did perform better by the end of the year. So this effect again says, well, when you introduce a technology that teachers have been told will improve how your students will perform, in fact the students perform better, again, even though sometimes the technology is not responsible for this. Now, this is the point at which I sometimes get asked, okay, so what's the problem? After all, student outcomes have improved. Do we really care whether it was the game or one of these expectation effects? And the answer is yes, we care very much, and there are at least three reasons for this. The first reason is that expectation effects go away after a while, usually a relatively short while. So what worked one semester might not work the next semester. So the gains that you make tend to be short-lived. The second reason is resources. When we're evaluating whether it's worthwhile using a technology in the classroom, it's our responsibility to make sure that we're picking the best possible technology for that use. So in one case, games might be the best technology, but we won't know whether they're better than another technology that might have less of an expectation effect upon introduction, unless we control for these expectation effects. And third, if we are to use games in the classroom in better and better ways, we need to build up a body of research that we can rely upon. and we cannot rely upon research that has not in any way, shape, or form factored in the presence of expectation effects. So, how do we control for expectation effects? Well, we can do it either informally or more formally. Informally, here are 5 suggestions. First, try to have multiple instructors use the technology. That'll allow you to start to get a little bit of an idea of whether something like a Pygmalion effect is present. Second, try to have multiple classes use the technology. Third, have a third party observe instructors and classes. In many cases, a third party will notice things that you as an instructor might not in terms of, for instance, placebo and halo effects. Fourth, look for overall trends in class performance. If you see an initial boost in performance that then seems to decline over the term, you might well be looking at the declining influence of expectation effects. And finally, use end-of-term attitudinal surveys to get a little bit more insight in terms of how your students regard the technology that you've just introduced in the form of the game in the classroom. A full-fledged experimental design to control for expectation effects requires a total of 6 different groups. And to be realistic, most people won't have access to the resources needed to manage an experiment of this size. But in general, it is possible to control for subsets of expectation effects with smaller sets of groups. So what I've done here in this diagram is outline the hierarchy of how important each group is. So the basic group, the most essential group, is to have one group that's getting the experimental procedure taught by a teacher who expects the procedure to have some benefits. That's group E. And to compare it to a group being taught by a teacher with the same expectations or the same teacher, but who are not receiving the treatment, in other words, who are not playing the game, and that would be group A. If you want to control for additional expectation effects, you can add groups C and B, or groups C and B. Group C is a group that's being taught by a teacher that expects that the game will benefit their students. But in this particular class, they're not using the game, they're using instead some other technology that's been added to the mix that has, however, no direct relation to the educational outcomes that the game is supposed to address. In other words, here you're controlling for Hawthorne effects. And the other group, which is group B, is a group which is being taught by a teacher who does not expect games in the classroom to have any particularly positive effect and who are not playing the game. And this group controls for John Henry and begins to control for Pygmalion effects, and that's group B in this diagram. And finally, if you can go all the way to the 6 groups, the last 2 groups are desirable but not as important as the other 4, and those are group D, which is a Hawthorne control group being taught by a teacher who does not expect the game to have any particular benefits, and group F, which is a group that's receiving the full experimental procedure, in other words, being taught with the game, but being taught by a teacher who does not expect there to be any benefits. In other words, this is a full control now for Pygmalion type of effects. The last topic I want to cover in this podcast is that of effect size. So we're talking about introducing a new tool in the classroom. It'd be nice to know how much effect it has. If it has a vanishingly small effect, well, is it really worth the time and effort to make the change? Wouldn't you be better off introducing something else instead? So you'd like to have some way to determine how well introducing a game in the classroom did. Now, a standard way to report this would be to say something like, well, the distribution curve for grades in the classroom went up by so many points. The trouble with that can be seen when you look at this diagram, which is drawn from a paper by Coe that I reference at the end of the podcast, and that's the following. In both of these scenarios, you have a before, the dark line, and after, the dotted line, set of scores being compared. In both cases, the number of points by which the distribution shifted is the same. But in the first case, we'd be looking at a very dramatic difference in terms of how students did, while in the second case, the case on the right, you'd be looking at a scenario where you say, well, there's some change, but not all that much. So you need some way to compare results between either before and after or a treatment, no treatment group that gets around this difficulty. There are several different ways to approach this. The method I recommend is to look at Cohen's effect size. And Cohen's effect size does something very simple. It says, well, let's take the difference between the means of group A and group B, and group A is generally taken to be the group after, group B is taken to be the group before, but what we do is we take the absolute value of that, so it's always going to be the positive result of that difference anyway. And then you say, well, instead of reporting just the difference between these two means, you make this a standardized difference by dividing it by the standard deviation of the sample you're looking at. Now, there's a little bit of a complication here, which is that there's no guarantee that the standard deviation in the before and after group is going to be the same. So you need to create something that's called the pooled standard deviation. So in the denominator here, what you have is this formula which simply says, well, take the number of participants in group A, subtract 1 from that group, and multiply times the standard deviation squared of that group, and then add to it the same formula for group B, and divide those two by the sum of participants in the two groups, subtract 2, and take the square root of all of that. That sounds like an awfully complicated formula, but it's easier to see its meaning when you realize that if they have exactly the same number of participants in both groups, then this reduces to just being the root mean square average of the standard deviation for the two groups, and in the cases where they have different numbers of participants, it's simply a form of weighting by the number of participants the two standard deviations. Okay, so from Cohen's effect size index you get a number out, and one question is, what does that number mean? And Cohen came up with some rough rules for what he called a small effect size, a medium effect size, and a large effect size. Some people have argued that when you're doing studies you should drop the small, medium, large denominations and simply say, look, here's the number I got and that's it. There have been several other studies, however, that have said actually Cohen's rules of thumb, while rough, do have some meaning to them, and it's worthwhile keeping them in mind. So let's take a look at what these effect size numbers look like for each of the scenarios. All the diagrams we're about to look at were generated by simulations. This is not actual experimental data. Before is indicated by the unshaded set of bars in the histogram. After is indicated by the shaded set of bars. So for the first scenario, we're looking at an effect size of around 0.2, and this is what Cohen called a small effect size. This type of effect size, from my experience and my review of the literature on gaming, is one for which you'd say, well, that was interesting, but significant work needs to be done for this to be a really useful intervention in the classroom. There may be some promise, but overall it's not quite ready as is. A medium effect size is what Cohen called an effect size of around 0.5. Things are getting a little bit more interesting here, and at this point the results are what I would call a good result, worthwhile repeating, but with more refinement still desired. Finally, a value of around 0.8 is what Cohen called a large effect size. And a value of this magnitude is what I would say is a thorough success in the world of educational gaming. This is the point at which the introduction of games in the classroom should be viewed as a new standard educational methodology you should definitely adopt, and probably doesn't even need much more refinement before other classrooms can go ahead and adopt it as well. So effect size gives you both a tool by which you can compare results when you're doing checks for expectation effects, and they also give you a handy ruler with which to say, well, how successful was this experiment? All right. So that's it for this podcast. As always, here are the associated resources. In closing, I would like to propose the following small exercise to you. Pick a couple of papers in an area of application of technology to education that you find particularly intriguing. It could be games in the classroom, or it could be something else. Then apply the tools and methodologies we've discussed in this podcast to those papers. Does the application of these tools and methodologies change your opinion of these papers? Favorably? Less favorably? What would you recommend doing as a result of this analysis? Why? In the next podcast, we'll look at educational gaming from a designer perspective. Until then, enjoy playing the games, but don't forget to take a second look at the data.